Okay, so this section kind of follows from what we did in section 2. We saw how the zeros of polynomials were an important tool not only for graphing the functions but also for knowing what the solutions to polynomial expressions are, which are an important thing to know how to do. So here we've got to use some kind of some procedures and some thought into figuring out what the zeros are. Now, in this case, most of the time they're rational zero. There's at least one, not rational zero, well, yeah, rational zero, meaning an integer, a whole number, or a fraction. Most of the time, these problems are such that they have at least one integer zero, and then you can find the other ones that are not integers. The reality is any general polynomial is most likely not going to have rational zeros. You're going to have to use some other techniques, but this again gives us some skills on manipulating mathematical expressions. So number one. So one thing you actually might look at this and think I could do grouping. I could use grouping, which I could, but let's not use grouping. Let's use what we're learning in this section, which is what are the possible rational zeros of this. So what you do is you take the factors of 4, which are plus and minus 1 and plus and minus 4, and you divide those by the possible factors of the coefficient in front of the highest order term, which in this case is 1, so we're going to divide that by plus or minus 1. So this leads us to 4 possibilities. You have plus or minus 1, because you have plus 1 divided by plus positive 1, negative 1 divided by negative 1, which gives you a positive 1. Or you can have the different signs. That would give you negative 1. Or 4 divided by 1. And again, you can have plus or minus 4, depending upon if you choose both positive or both negative, or different negative positive. So those are our 4 choices. So then normally what you do is, because we're talking about factors here, we can use synthetic division to see if any of these are zeros, and you do that by taking the original polynomial, which in this case is a third order polynomial, and you try either plus 1 minus 1, plus 4 minus 4, and because these are zeros, then you just can use the same sign. So we got plus 1, we got minus 1, plus 4 minus 4, and usually plus 1 is a good place to start. So let's just try there. This is good a choice as any. It's more likely to be a small number than a bigger number. Okay, so we bring down the 1. So you get 1 times 1 is 1. Negative 4 plus 1 is negative 3. And I've got a number wrong there, so that's negative 1. So 1, negative 4, negative 1, 4. Okay, so 1 times negative 3 is negative 3. Negative 3 plus negative 3 is negative 4. And 1 times negative 4 is negative 4. Yeah, it does together. That's what you're looking for, 0 remainder. So that means x equals 1 is a 0. It means x minus 1 is a factor. So let me just write the equation out again here. So we get x cubed minus 4x squared minus x plus 4. So one thing you could do is you could say that g of x is now going to be equal to the factor times something else. And this something else is going to be what's determined by these coefficients. So this is the x squared term, this is the x term, this is the right one. So you have x squared minus 3x minus 4. And at this point, you got a second order polynomial, which means you can use a quadratic formula, you can use completing the square, you can use observation. In this case, you could use observation to do it. You could factor this. So you have, what two numbers multiplied to give you 4? Well, 1 and 4. Because this is negative, there's going to be a plus part and there's going to be a minus part. And because the result here is -3, then the -4, the larger of the two, has to go with the negative sign, and the smaller of the two goes with the positive sign. And I forgot to put an x in there. So you'd have x -4. So now it's completely factored. We already know what one of the zeros, x equals 1 was 1, 0. Then you have the next factor of x plus 1 has a 0 of x minus 1, and the factor of x minus 4 has a 0 of 4. So those are your zeros. These are your factors. Another way of kind of representing this is if you took x cubed minus 4x squared minus x plus 4 divided by x, take this first factor, x minus 1, that's equal to x squared minus 3x minus 4 with no remainder. Now, I chose 1 here, but as you can see, I could have chosen -1 and +4. Let's just do that. So in this case, 3 out of the 4 possible zeros were actually those rational values. So, but you can see if I do this with the same initial equation, use -1 instead. So you bring down the 1. 1 times -1 is -1. Make sure I did that right. -4 minus 1 is -5. -1 times -5 is +5. -1 plus 5 is 4. -1 times 4 is -4, and you get 0. So what we're left here is the factor x plus 1 times x squared minus 5x plus 4. And again, from observation here, what two numbers to multiply together give you 4? 1 and 4. This is the same sign. So these either have to be both positive or both negative, but because the middle term is negative, then we know they both have to be negative. So one of them is 4, one of them is 1, and you get the same factored form, the same zeros. And then if we chose x equals 4, do the same thing. So bring down the 1. 4 times 1 is 4. Add these to get 0. 4 times 0 is 0. -1 plus 0 is -1. 4 times -1 is -4. 0. And what you're left with here is you got x minus 4 times x squared minus 1. But you can factor these last two, x plus 1, x minus 1. So you get the same result. So that's probably why they chose that problem, because they're, you're guessing 75% of the time you will be right. The only one was wrong is -4. Okay, so number 2. So again, you're going to look at the factors of 9, which are 1, 3, and 9. So you get a plus or minus 1, plus or minus 3, plus or minus 9, all divided by the factors of 3, which are plus or minus 1 and plus or minus 3. So let's just start with 1 in the denominator and then have these 3 possibilities. So from there you get, so plus or minus 1 divided by plus or minus 1 is plus or minus 1. Plus or minus 3 divided by plus or minus 1 is plus or minus 3. And plus or minus 9 divided by plus or minus 1 is plus or minus 9. Then you've got here, 3 is the denominator, so you can have plus or minus 1/3. The second one plus or minus 1, which is just a repeat of that first one, and plus or minus 9/3, which of course is plus or minus 3. So you can see this is a duplicate. This is a duplicate. So we end up with these 8 different possibilities. So we're going to, we're just going to try again. Let's try 1 again. Okay, so we're going to try positive 1. 3 times 1 is 3. Negative 19 plus 3 is negative 16. Negative 16 times 1 is negative 16. Add those together, you get 17. 33 minus 16 is 17. Then you get 1 times 17, so you get 8. So it's not 0, but we don't want to, we can use that information possibly later. So one of the, when x equals 1, f of x equals 8. So this gives us a point 1 comma 8. It's not 0, but it gives me something to plot later on. So if I want to plot this polynomial, I've already got a point. Okay, so that didn't work. Let's try the next one. So let's try negative 1. So we got 3, negative 19, 33, negative 9. Now one thing about this is the y value is not too big. It's only 8. So that would make me think that maybe this is 1, so maybe negative 1 or positive 3, which are the two possibilities that are close to that, makes me believe that that might be a choice. So if negative 1 doesn't work, then we'll try positive 3, or I guess a third could possibly work. So we'll start with the integers. Okay, bring the 3 down. 3 times negative 1 is negative 3. Add those together, you get negative 22. Negative 1 times negative 22 is positive 22. Add these together, you get 55. Negative 1 times negative 55 is negative 55. Add these two together, you get negative 64. Okay, so again, what that means is when x equals negative 1, that f of x equals negative 64. So, well, notice one thing. F of 1 was 8. F of negative 1 was negative 64. The y values cross the x-axis. So here's 1. That's going to be 8. Negative 1 is negative 64. It's way down here. So, if you just draw a straight line between these 2 points, you'd end up somewhere there. So if the 0 is going to be a rational number, it's going to be one of these choices, and negative 1/3 looks like it might be a possibility. So let's try that. Or positive 1/3. Why am I picking positive 1/3 instead of negative 1/3? Because this one's way down here. So it's going to cross the y-axis here, and it's going to, and you can kind of tell too if you go back to the original equation, where does it cross the y-axis? Negative 9. So that's right there. So it looks like positive 1/3 might be a good choice. So 1/3. So you got 3, negative 19, 33, negative 9. Okay, bring the 3 down. 1/3 times 3 is 1. Negative 19 plus 1 is negative 18. One-third times negative 18 is negative 6. 33 minus 6 is 27. 1/3 of 27 is 9. 0. What about that? So that means that x equals 1/3, or that's 0 factors x minus 1/3. Also, what we have left over, we can say that the original function is now x minus 1/3 times some quadratic, which is going to be 3x squared minus 18x plus 27. Now notice I've got a 3 common factor, so I could factor that out. 3 times x minus 1/3 times x squared. So divide this by 3, you get 1. Divide that by 3, you get 6. Divide that by 3, you get 9. At this point, you can factor the second one. So it's got x, two numbers multiplied together give you 9. 1 and 9, 3 and 3. 3 plus 3 is 6. So that looks like the good choice. It's positive. So you get x plus 3. So what you can say is, the zeros in this case are going to be x equals 1/3, and x equals -3. So there's a multiplicity of zeros here. We know the y-intercept is -9. We also know that at -3 that it has to come back down again. And because it's a multiplicity of 2, it's going to go like that. So you kind of have something kind of like that. They didn't ask us to plot it, but let's go ahead and plot the function. So we could plot the original version here instead of the factored version. Okay. So we got 3x cubed minus 19x squared plus 33x minus 9. And I just note, well, no, you can't divide everything by 3, so yeah, you couldn't simplify that down. Make sure I did that right. Yeah, okay, we'll find out when I plot it, because we should have, so we have, what do we say we had? Does that make sense? I got -3 here. Oh, it should have been +3. No, it's +3. So what did I do wrong? Oh. Okay, sorry about that. That should have been negative. So those are negatives. That's going to be positive. That's why it's good to plot something. Okay, so there we go. So you can see that's what happens. So you've got a 0 here at 1/3. You've got 2 zeros at 3. So I got to redraw my graph here. Yeah, I should have realized that. Why that didn't make sense. I did subconsciously think about it, but so you've got a 1/3 here. You got that's 1, 2, 3. So -9, you go x-intercept, so you come up here, go through a 1/3, you go through 3, so it's going to go up, and then it's going to come back down again, and then it's going to not intersect, but it's just going to touch. So, what value of x might I choose to do somewhere in between? Well, I could take the average of 3 and 1/3, 3 plus 1/3, take the average of those. 1.5 is pretty close to it, so I might just use 1.5 to get a point here to see how far this thing goes up. And I probably pick a point like x equals 4 to see how quickly the function rises, but they didn't ask us for that. Okay, next group. List all the possible rational zeros of f. Sketch the graph of f so that some of the possible zeros in part A can be disregarded. And then determine all real zeros. Okay. So let's think about that. Yeah. Because, listing all the possible rational zeros, there's going to be a lot of those. So it says sketch the graph of f so that some of the possible, how do you sketch a graph without having the zeros? So that might be an interesting thing. Okay, so let's think about that. Let's do part A. possible rational zeros. So the factors of 16 are 1, 2, 4, 8, 16. So that's the factors, and that's for the numerator. And for the denominator, you could have plus or minus 1, plus or minus 3. So we got a lot of choices here. You've got all of these because you divide all of them by 1. So you got plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. Okay, and then you can take all these divided by 3. So we've got plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 8/3, plus or minus 16/3. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2, 20. So, you know, if there's only one real zero, or one real rational zero, then we could do 19 times and get the wrong answer. So we definitely want to see what's going on here. So one thing you could do is we do know the y-intercept, which is 16. So let's just point that up there, 16. And the end behavior says that it's going to look like this. So there's a couple of options. There's it could come down like this and then loop back up like that, go through there, come back down like that. Or it could go, we could have a, you know, you could have a multiplicity of zeros. So you could have something that came down like that and touched and went up and then back down like that. Or you could have where it goes through here and then it goes up there and then comes back down like that. And then you'd have all of them positive. So one thing is it's probably not going to be these small numbers, just because to get from 16 down to 0 in that amount of space is probably unlikely. Plus or minus 16 or 8 is probably not going to be, probably not reasonable. So I'm going to get rid of those. I'm going to get rid of those. Okay. Now, what we need is a few more points, so we could use synthetic division just to evaluate the function at a few values of x. You can do that by doing synthetic division. If the remainder is not 0, then that gives you the value of the function. So one thing is if you put in -1 and it's greater than 16, then you would expect it to look like this. If you put in -1 and it's lower than 16, you probably expect maybe this kind of situation. That's what I'm guessing. So let's put in -1. And the function, I've already forgotten it, -3 plus 20 minus 36 plus 16. Okay, -3 plus 4 plus 3 plus 3. Okay, 23, -23. Add these together, you get 52, 59, -59. -1 times -59 is going to be positive 59. So that's going to be 75. So that's way up here. So this thing is taken off down there. So I think we can neglect all the negative values. I don't think those are going to work. Now let's do 1, positive 1. See what that does. Because if we do positive 1 and it's still positive, or if it's negative, then it might be one of these fractions. If it's still positive, then it's probably not, it can't be those fractions. So let's put negative, put these in here. Okay, bring down the negative 3. 1 times negative 3 is negative 3. Add these two together, you get 17. 17. Add these two together, you get negative 36. 17, that's 19, I guess, 19. Negative 19. And you get negative 1. 1 times negative 19 is negative 19. And so you get 3, or negative 3. Is that right? Bring that down. 17 times 1, negative 19. Okay, so you can see at 1 it's down to negative 3, so it must cross somewhere. So what's the closest? 2/3. Okay, so let's do 2. And all we need is one of them. We just need 1, 0, and then we have a quadratic remaining after that. So I'll put 2/3 here. So you got negative 3, 20, negative 36, 16. Okay, bring that down. Negative 3. Okay, 2/3 times negative 3 is negative 2. So 2/3 times negative 3. See, these cancel out. You get negative 2. Okay, add these two together, you get 18. 2/3 of 18 is 12. Add these two together, you get negative 24. 2/3 of negative 24, negative 16, and you get 0. Doo-doo! So that's one of them. So what we have left is that original function is going to be x minus 2/3, because this is the 0. So x equals 2/3 is 0. The factor is x minus 2/3. And then what we have left is negative 3x squared plus 18x minus 24. And you can factor out a negative 3. So you get negative 3 times x minus 2/3. So negative 3, you're left with x squared minus 6x plus 8. And now hopefully we can factor this, so which we can. You know, what two numbers multiplied together give you 8? 1 and 8, 2 and 4. This is positive, so these have to be either both positive or both negative. Since the middle term is negative, I know they have to both be negative. So you get negative here, negative there. So I'm going to be adding the terms quantity-wise. So 2 plus 4 is 6, which is what I have. So put that in there. So that's the factored form. The zeros are x equals 2/3, x equals 2, and x equals 4, which justifies our earlier observation that, you know, -1 gave us this really big number, which meant it was very unlikely it was going to come all the way up here and then back down again. So let's plot that thing. Make sure it agrees. So you got negative 3x cubed plus 20x squared minus 36x plus something. I forgot what it was. Let me graph that. And then I didn't like that. Okay, 16. Okay, plus 16. Negative 3x cubed plus 20x squared minus 3. Okay, graph that. So there you go. And you can see here's the first 0 at 2/3, 1 at 2, 1 at 4. And if we zoom out in the x direction, you see where it, you know, it crosses the x-axis at negative or positive 16. And then f of -1 was this -75. So you see how that, so that's why I thought it had to be somewhere around here for at least one of the zeros. Okay, now we're going to find the given zeros, or given one zero, which in this case is a complex zero. The key thing here is anytime you have a complex zero, the other zero has to be the complex conjugate. So if we have x equals 5 plus 2i, we already know that x, the other zero, the other complex zero is going to be 5 minus 2i. And once you know both of those, you can multiply them together. So, you know, these are, again, the zeros. So the corresponding factors are going to be x minus 5 plus 2i equals 0, and x minus 5 minus 2i equals 0. So we have the original expression is going to be x minus 5 plus 2i times x minus 5 minus 2i, and then this third factor, which we're going to figure out in a second. But to do that, we're going to multiply this thing out FOIL-wise. So x times x is x squared. Then you've got minus 5 plus 2i times x. And then you got minus 5 minus 2i times x. And then you're going to have the last one, which is going to be negative times a negative, so it's going to be positive. And 5 plus 2i times 5 minus 2i. So this times that with the positive sign. So you get this these two together, which is this. You get the outside together, which is that. Okay. Now we have to do a little simplification. So let's remove the parentheses. So you're going to have negative 5 times x. So that's going to be negative 5x. Then you have negative 2i times x. Negative 2i times x. Okay, the next one, you'll have negative 5 times x. So that's negative 5x. And you have negative times a negative, so that's plus 2i times x. Negative times negative is positive 2i times x. So that's these two terms. And then the end part, you have to use FOIL again. So there you'll have 5 squared, 5 times 5. You'll have plus 2i times 5 from here, and then you'll have minus 2i times 5 from the outside. And then you'll have minus so when you multiply these two together, you get minus 4i squared. Okay, so let's see what we can clean up. That cancels out with that. That cancels out with that. So we get rid of all the imaginary stuff. So what we're left with is x squared. We got minus 5x twice. And down here we have 25. And here we have plus 4. Because I squared is negative 1, so you get negative 1 times negative 4. So we get plus 29. So that's the bottom line of what if you take the two imaginary ones and you multiply them together. Okay, now we still don't know what this third factor is here. This thing right here. So the way you do that is you take the original expression. So let me add a page right in here. So you take the original expression, and we're going to use long polynomial division. and we're going to divide by this, which is a thing that doesn't have any real roots, that quadratic. So you're going to have x squared minus 10x plus 29. You're like, oh, that's never going to work out, but it does. Okay, so you say, okay, what do I need to multiply x by, or what do I need to multiply x squared by to get x cubed? Well, the answer is x. Okay, so then we multiply everything by x. So we get x times x squared is x cubed. Negative 10x times x is negative 10x squared. X times 29 is 29x. But we're really subtracting it, so we do that. So when you add these two to get 0, which is the object, then you have negative 7x squared plus 10x, because you get a negative times a negative. So it's going to be positive 3x squared. And then you have negative 29 minus 29, which is negative 30x. And then you bring this down, plus 87. Okay. What do I need to multiply x squared by to get 3x squared? Well, the answer is plus 3. Okay, so let's make sure we got it. Remainder of 0. This is the moment of truth to make sure that this part's right. So 3 times x squared is 3x squared. 3 times negative 10 is negative 30. 10x, so it's negative 10x times 3, and 29 times 3 is 87. Leave little faith. You subtract that, you get 0, which says that this is a factor of that. So now we can go back up here, and the answer is x plus 3. So the original function has 2 complex zeros and 1 real 0. The actual 0, so what they're asking for is use the given 0 to find all the other zeros. So in this case, the second 0 is 5 minus 2i. And the other 0 is going to be, well, x plus 3 equals 0. That gives you x equals negative 3. So if I plot this function, I should have one x-intercept at negative 3. And then that's it. So let's see what this thing looks like. So you got x cubed minus 7x squared minus x plus 87. Graph it. And there it is. So you can see it crosses the x-axis at negative 3. And this thing doesn't dip far enough to get through the x-axis again. So one of the issues here, if you were trying to plot this function, is you'd be able to get one real 0 and one y-intercept, but you have no idea what's going on here. So how would you do that? Well, if you picked, we at least know the end behavior. You could pick one point. If you pick positive 1, you'd have that, which wouldn't tell you a whole lot, except that it's lower here, so you'd be able to at least maybe predict that was where you might have a maximum, but you'd have no idea where it went down there. This is where calculus would tell you exactly where this happens and exactly where the other thing works out. But we can only do so much pre-calculus. If you want to know the answer to that second question, you have to take calculus. Okay, so the game, same thing. So if one of the x's, the x-intercept is negative 3 plus the square root of 2i, the other complex 0 is negative 3 minus the square root of 2i. So we're going to multiply those together. But that, again, that's where you got to be careful here. So that's the 0. The factor is this. So that's the factor. Likewise, this is the factor. And I would just leave them in this form. Make sure I did that right. I have parentheses. Oh, yeah, that's. I thought that was something was wrong there. So this is I. Close that parenthesis. So these two together. Notice this is plus, this is minus. Then you know the parenthesis. So those are the factors. So what we need to do is multiply this thing out. And do the same thing that we did previously. And then there'll be another third factor. That's what we've already got two factors. We just need a third one, which is probably going to be, has to be a real zero. You always have at least one real zero with, well, in this case, it's a fourth order one, so maybe it might not. There could be 2 or 0. We don't know yet. We'll see. We'll find out. So we're going to multiply this thing out again. So you'll get x times x, which is x squared. Then you'll have negative, what I'm going to do, you know, the outside, you're going to have x times this whole thing. So you'll get the negative sign here is that negative sign. X is that. And then you multiply by negative 3 minus the square root of 2i. So that's outer. Inner, you're still going to have negative. Still going to have x. And you multiply by this thing, which is negative 3 plus square root of 2i. So that's the outer. That's the inner. And then you've got the next one. So you get negative times a negative. So it'll give you positive. And then you have negative 3i plus the square root of 2, negative 3 plus the square root of 2i. That's this term. And you multiply by that term, which is negative 3 minus square root of 2i. Okay, so we're going to distribute x, negative x, to each one of these two terms. So you'll have negative x times negative 3. So that's positive 3x. Negative times a negative 3x. So that's everything. You have a positive times a negative times a negative. So it's going to be positive. Positive square root of 2. Positive times, okay, square root of 2x times I. Okay, so that's those two. Then we have this part, which is negative times negative, so it's positive. So it's got plus 3x. These are always the same. Then you have negative x times positive the square root of 2i. So you're going to have, instead of have plus the square root of 2i, xi, you're going to have negative the square root of 2xi. So that's these multiplied out. Then use FOIL down here. So you can have negative 3 times negative 3, which is positive 9. Let's do outer first. Negative 3 times negative square root of 2i. So that'll be positive. Negative times a negative is positive. You got 3 square root of 2i. So this times that. Okay. Then you do the inner, which is going to be minus 3, because you've got negative times positive. So it's negative 3 square root of 2i. And then you've got last, you've got negative times positive. So that's going to be negative square root of 2 times the square root of 2, which is that squared, and then you got I squared. Okay, let's do some canceling out here. That cancels out with that. This cancels out with that. So what you're left with is x squared. 3x plus 3x is 6x plus 9 here. And here you're going to have the square root of 2 squared, which is 2. You still have the negative sign. But I squared is negative 1. So negative times negative 1 is positive, so it's going to be plus. And the square root of 2 squared is 2. So finally you get x squared plus 6x plus 11. Okay, so that's what these two multiplied together. This and its complex conjugate. Now what we need to do is divide this by that. and we'll get a polynomial. We'll get a second order polynomial, which we should be able to factor. So let's add a page here. So we're going to take x to the fourth plus 3x cubed minus 5x squared minus 21x plus 22. Divide that by x squared plus 6x plus 11. Okay, what do we need to multiply x squared by to get x to the fourth? The answer is x squared. X squared times x squared, x to the fourth. X squared times 6x plus 6x cubed, x squared times 11, 11x squared. So subtracting that. So these go to 0. Then you've got 3 minus 6, which is negative 3x cubed. You've got negative 5 minus 11, which is negative 16x squared. And then you can bring the next term down, negative 21x. Okay. What do I multiply x squared by to get negative 3x cubed? Negative 3x. Negative 3x times x squared is negative 3x cubed. Negative 3x times 6x is negative 18x squared. Negative 3x times 11 is negative 33x. Okay, so we're subtracting that. So this goes to 0, negative 3 plus 3. Then you have negative 16 plus 18. Negative times a negative is a plus. So you get plus 2x squared. And 2x squared. Here we have negative 21 plus 33, which is going to be plus 12x. And then you bring down 22. Okay, so what do we multiply x squared by to get 2x squared? So the answer is 2. 2 times x squared is 2x squared. 2 times 6 is 12. So we get 12x. 2 times 11 is 22. So that looks good. You subtract those, you get 0. So what that means is that this original polynomial here, wherever it is, this one right here, is going to be, so f of x, we'll write it up here. So f of x is going to be equal to x squared plus 6x plus 11, which is this term, times what I've got up here, which is x squared minus 3x plus 2. That's because the remainder is 0. So this, if you factored this, you'd end up with these two solutions. Now, the question is, can we factor this remaining polynomial? Which we can. So the question is, what two numbers multiplied together give you 2? 2 and 1. They have to be the same sign because, so it's either going to be negative, positive 2, or positive 1, or negative 2 and negative 1. If I add this, I'll get positive 3, so that's not the right answer. If I add these together, I'll get negative 3, which is the right answer. So I'll get x minus 2 and x minus 1. So a factor of x minus 2 is the same as a 0 of x equals 2, and a factor of x minus 1 is the same as a 0 of x equals 1. So I can go back here now. So my other zeros are going to be, what did I say they were? 2 and 1 and 2. So it's going to be x equals 1 and x equals 2. So those are the 4 zeros. And you have 4 zeros because it's a fourth order equation. This was a third order equation, so we had 3 zeros. In this case, we have 2 real and 2 complex. Now with a fourth order, you can have 0 real, 2 real, or 4 real. Okay, so let's plot the function. What we should see is the thing cross. It's got a positive highest order term, so it's going to be end behavior is going to come down from positive infinity. It's going to cross at x equals 2, come back up at x equals 1, then it'll stay above the x-axis for the other part of the graph. So let's just plot this thing. X to the fourth plus 3x cubed minus 5x squared minus 21x, and I forgot what the other, plus 22. Okay, plus 22. So there it is. And so that looks just what we're like talking about. Here's x equals 2, here's x equals 1. It goes back up, but it never loops back down again. It doesn't cross the x-axis. Again, how would you know? You could get the y-intercept, which would be equal to 22 from this number right here. So that's 22. You know, to get this part of the curve, you'd have to, without calculus, you'd have to just pick a couple numbers and see what happens. Calculus, you could find what this point is and what this point is. These values of x, which would give you where it's what we call a local minimum, maximum here, local minimum. Okay, moving on. Okay, find all the real zeros of the function and write the polynomial as a product of linear factors. Okay, so in this case, they're not giving us any help. So we kind of have to think about what's going on here. So let's use some of the stuff we've learned previously. You know, this doesn't have any intermediate terms. So notice we did a problem kind of like this, but it had an x squared term in the middle. So the first thing you would do is you'd think, okay, well, if I had x squared minus 81, I'd know that was going to be x plus 9, x minus 9. You know, one has to be positive, one has to be negative, so there's no intermediate term here. And they have to be the same, so they balance out. And we know that 9 squared is 81. So the only difference is we have x to the fourth. So instead of having x here, we'd have x squared. So you'd have x squared plus 9, x squared minus 9. Now here, there are no real zeros, but you can find the complex zeros by saying that x squared plus 9 has to equal 0, x squared equals negative 9, x equals plus or minus the square root of negative 9, which is going to be plus or minus 3i. So the negative square root of negative 1 becomes I, square root of 9 becomes 3. So those are the zeros. The factors would, you know, x equals 3i. The factor is x minus 3i equals 0. And the 0, x equals negative 3i is the factor x plus 3i. So these are two factors. Those are the complex factors. And then over here you've got x squared minus 9 equals 0. So you'd have x minus 3 and x plus 3. Just kind of the same process here. Except we had 81. Here we have 9. So these are the factors. So the zeros would be, you know, if I want to get the zeros, x minus 3 equals 0 or x equals 3. So that's the 0. And then you'd have x plus 3 equals 0 or x equals negative 3. So it says find all the zeros. So the zeros are going to be these and these. And in terms of the original function, we use the factors. So we have x minus 3i, x plus 3i go back up here where it's factored, x minus 3, x plus 3. So that's the answer for that one. Okay. Now the next one's not so easy. We could have 3 real zeros or 1 real zero. We have to have at least 1 real zero because the complex zeros always come in pairs. So when you have 3 zeros and 2 of them are complex, then that means there's 1 left over, which has to be real. So what I would use here is the possible rational zeros. So you'd have plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, divided by plus or minus 1. So you take this and you take plus or minus 1 here. So we've got 8 different choices. So again, I'm going to choose 1. It's always a good choice. Notice that f of 0 is negative 10. So let's just draw a little graph here. What do we know about this function? Well, the end behavior is like this. The y-intercept is negative 10. Okay, so let's see what we get at positive 1. If it's positive, then we know we have a thing crossing here, but that problem there is it's not going to be, it couldn't be an irrational 0. Anyway, let's see what we get. So you bring the 1 down. Oh, not going to bring it further than that. Bring the 1 down, and I need to put 1 up here anyway. So we're going to try 1. X equals 1. Bring that up. 1 times 1 is 1. Negative 5 plus 1 is negative 6 plus 1 is negative 5. 1 times negative 5 is negative 5. 13 minus 5 is 8. 1 times 8 is 8. And then we get negative 2. So what that says is f of 1 equals negative 2. Okay, so that's going to be about right there. So it seems too close to the x-axis for me to have for this thing to go straight through. It can't to be 2, so it could look something like this, where it touches the x-axis at 2, comes back and then goes like that. So let's try 2. So you have 1, negative 6, 13, negative 10, 2. 1. 2 times 2. 2 times 1 is 2. Add these together, you get negative 4. 2 times negative 4 is negative 8. 13 minus 8 is 5. 2 times 5 is 10. You get 0. Yay! Okay, so well, that might be actually going through it too. That surprises me. Did I do this right? Negative 5, 8, 8. Yeah, well, it does work out. Anyway, so what we know is one of the zeros is x equals 2. One of the factors is x minus 2. What we've got left is x squared minus 4x plus 5. And if that factors out, that has to equal 0. So we look at that and we say, can we factor that x minus something x? So these have to both be positive or both negative. Factors of 1 and 5 are 5 or 1 and 5. If you add these together, you get 6, which doesn't work out. So it's not something we can factor easily. We can do completing the square or the quadratic formula. So let's use completing the square. So what we would do is we would move the 5 to the other side. It becomes negative 5. So then we take negative 4 divided by 2, square it. So that's negative 2 squared, which is 4. So we add 4 to both sides. So that becomes x minus 2 quantity squared is equal to negative 1. Well, we're in trouble because that's negative. So no. So that gives says we have no real zeros. But we need to come up with the complex zeros. So what we do is we take the square root. So you'd have plus or minus the square root of negative 1, which would be plus or minus I. So the square root of negative 1 is I. Add 2 to both sides, so you get 2 plus or minus I. So the other two zeros are going to be this, and hence the two factors are going to be x minus 2 plus I and x minus 2 minus I. And we said the other factor, which we got from this, was x equals 2, or factor x minus 2. So I think that's what they're looking for here. Find all the zeros, which you did, write the polynomials of product of linear factors. So what we see is we have, in this case, we have one real zero at x equals 2, two complex zeros. So let's plot this function, which I've so where is it? Oh, there it is. So we've got x cubed minus 6x squared plus 13x minus 10. So we've got graphed it there. And let's go to standard zoom here. And then we'll zoom out a little bit in the x direction. So yeah, it actually does work. So here you are at x equals 0, y equals negative 10. At x equals 1, you're at negative 2. Here's the intercept at x equals 2. And you can see that there's only one intercept. So we could zoom out a lot. But you can see there's no other x-intercepts. So it all makes sense compared to what we found out. But, going back to our initial, how we could pick something. So we took the y-intercept, we took the end behavior, we said, okay, if this thing keeps going in that direction, it looks like it's going to intersect the x-axis somewhere pretty close to 0. So that's why we chose positive 1 first. And we saw that it didn't quite cross the x-axis. So the next possible rational 0 was plus 2. So we tried that. And that did work. That left us with this quadratic, but we couldn't factor it easily. So we said, okay, we'll use completing the square. We got to this point where, we had a negative 1 here, and we said, that's a problem. That means we can't get any real zeros out of this. So, but we can still complete the square to find the the complex zeros. See if there's any more problems after this one. Okay, so we got 2 more. So I'm going to persevere here instead of taking a break. So number 8. So it's a third order polynomial. So we've got 1 real 0, 3 real zeros. The possible rational zeros are plus or minus 1, plus minus, well, what's the factors of 35? There's 5, 7, 35. So 5, 7, 35. The denominator is plus minus 1. So there are 8 possible rational zeros. Let's look at the end behavior. So it's this kind of end behavior because it's cubed. We have an x-intercept of 35. So most likely, if we have to come from this direction, we're going to cross the x-axis somewhere here. It has to be a negative one, a negative value. So it looks like either -1 or -5 might be a good choice. And we just need one. We need to get one real zero, and then we can factor. We can do the quadratic stuff easily. So what we're going to do is we're going to pick -1 first and see what that is. If -1 gives a positive value, then we'll try -5. Okay, bring 1 down. You get -1, 9, minus 1 is 8. 8 times -1 is -8. Add these together, you get -19, a positive 19. You get -19, so that's -16. Positive 16. Okay, sorry for a minute. So there's x equals -1 is positive 16. And we had 35. So it looks like -5 is probably the next best option. So let's try that. So we get -5. Okay, bring that down. -5 times 1 is -5. Add these together, you get 4. -5 times 4 is -20. Add these together, you get 7. -5 times 7 is -35. Add these together, you get 0. Yippee. Okay. So one of my zeros is x. Well, my 0 is -5. X equals -5. Or the factor is x plus 5. So that's the factor. That's the 0. What I'm left with is x squared plus 4x plus 7. So the question is, does this have any easy zeros? Well, it doesn't look like it, because 7 times 1 is 7. 7 plus 1 is 8. 7 minus 1 is 6. So it doesn't come out. So we need to use completing the square or quadratic formula. So we're going to use completing the square, especially since this is an even number there, so it makes life easy. So we're going to move this to the other side. So that's -7. Take 4 divided by 2. Actually, this is going to be, we're going to end up with the same situation. So we get 2 squared, which is 4. So we add 4 to both sides, and you can see that the right-hand side is still going to be negative, which means I have I'm going to have imaginary zeros. So we do the same thing that we did last time. You take the square root. So you get plus or minus the square root of -3, which is the same as plus or minus the square root of 3i. So the -1 becomes I. And then you subtract 2 from both sides. So you get x is -2 plus or minus the square root of 3i. So those are my zeros. My factors are going to be x minus -2 plus the square root of 3i and x minus -2 minus the square root of 3i. So these are the zeros, these are the factors. So the factored version is going to be x plus 5 times that stuff. So what I should find is that the graph will probably look something like this. It'll start off down here, it'll go through -5, it'll come up here, it'll go through positive, what was the number here? Positive 35. And then it either go like that or it might go down and back up like that. We don't really know. So let's see what happens. So we've got the original function is x cubed plus 9x squared plus 27x plus 35. Okay, so we graph this thing. There you go. You see the function crosses the x-axis at -5. We zoom out. You see it crosses at 35, so it actually wasn't even one of those choices. It was the actual loopy-doopy part here was between -5 and 0. That's why this number here, 16, f of -1 was 16. If you go here, you can see it's 16. That's why you might have, if you'd taken this point and this point, you might have thought that the intercept would be somewhere like -2, but we didn't know about this little flattening out thing. Okay, and I got one more. So number 9, we have the possible rational zeros. So luckily we have a 1 in front of x to the 4th. So we have plus or minus all the factors of 16. Which would be that. 1 times 16 is 16, 2 times 8 is 16, 4 times 4 is 16. So we've got 10 possible rational zeros. Now let's just we know one thing about this. Wait, two things. We know the end behavior, like that. No, actually it goes the other way, doesn't it? It's x to the 4th. It's positive x to the 4th, so the end behavior is going to look like that. And we have a 16 for the y-intercept. So, you know, it could come down, go through the x-axis, come back up, and then come back down again. So to go from 16 down to 0, that's pretty quick. So I might try positive 2. 16, 8, 4, these 8 and 16 are probably not going to happen. It's not going to take that long to get down to the x-axis. So I'm going to try plus 2. So that means I take the original function, take the coefficients, like that, and put a 2 in here. So bring that down. 2 times 1 is 2. Add these together, you get that. You get -4. Add these together, you get 4. 4 times 2 is 8. -16 plus 8 is -8. Times 2 is -16. You get a 0. So that was pretty good. So that is one of the zeros. Now if I'd chosen 1, let's just try 1, just to, even though I mean this could be another 0, but like I said, I didn't think that was going to happen. Let's see how we would use the results from this thing to kind of guide us. So we bring that down, we get here, add that together, you get -3. 1 times -3 is -3. Add these together, you get 5. 5 times 1 is 5. Add these two together, -11. 1 times -11 is 5. I mean, -11, add these together, you get 5. So what this says is that f of 1 is 5. So if f of 0 is 16 and f of 1 is 5, then you can see how it's coming down pretty rapidly. So that would, if I'd chosen 1, this would have told me, hey, 2 is a pretty good choice. Now we're still left with a third order equation. So we started with the fourth order equation. Now we got the coefficients for the third order equation. And you could kind of use the same logic. This is a third order polynomial. There's a y-intercept of -8. So if I'm coming up from here, then I'm still going to have to go through the x-axis somewhere here. Now it may go up here and go like that. It may come down. I don't know. But again, it looks like over here, when I was coming down, I got +2. So +1 or +2 might be a good choice. I mean, our rational zeros are going to be ±1, ±2, ±4, ±8. Again, those are the factors of this term. So let's try 1. So the coefficients are 1, -2, 4, -8. So bring this down. 1 times 1 is 1. Add these together, you get -1. 1 times -1 is -1. Add these two together, you get 3. 3 times 1 is 3. Add these two, you get -5. So you can see if f of 1 is -5, f of 0 is -8. So again, it looks like 2 might be a good choice. So we'll try 2. Same coefficients from the third order equation. Bring this down. 2 times 1 is 2. Add these together, you get 0. 2 times 0 is 0. Add these two together, you get 4. 2 times 4 is 8. Add these two together, you get 0. So we actually have we have 2 zeros at x equals 2. So what we know so far is we have 0. Our zeros are x equals 2 and x equals 2. So we have a multiplicity of 2 at 2, and then what we have left over is x squared plus 4. So that's our factors. So if we did the corresponding factors, the factor corresponding to x equals 2 is x minus 2. And the same thing here. So we get x minus 2 times x minus 2 times this thing. Now, if we could factor this, we would have, if we could factor it with real zeros, then we would do that. But you can see how we have x squared plus 4. So to find the other 2 zeros, we're going to set that equal to 0. Subtract 4 from both sides. Take the square root, you get plus or minus the square root of -4. So you can take the negative out, plus or minus the square root of 4i, and you get plus or minus 2i. So the final factored form of this equation is x. So our 2 zeros are x equals +2i and x equals -2i. And the corresponding factors would be x minus 2i equals 0 and x plus 2i equals 0. So that's what we'd have here, x minus 2i and x plus 2i. And that is the answer. Write all the zeros of the function and write the polynomial as a function of linear factors. So this would be part B. That's the polynomial. In terms of factors, the zeros would be these two and those two. So represent the polynomial as a product of linear factors. Those are the zeros. And let's just look at this function. Let's see what it looks like. So let's let me go back to the original function here. So I've got x to the 4th minus 4x cubed plus 8x squared minus 16x plus 16. And there it is. So you can see it touches the x-axis at x equals 2. That's because there's a even multiplicity of the factors. And if I zoom out in the y direction, you can see, it never comes back down again. It doesn't loop down and give us two additional roots. So that's why we have two complex roots. We have two real roots at x equals positive 2 and two imaginary or complex roots.